x is equal to 14 minus x. Transfer minus x becomes plus x is equal to 14. 2x is equal to 14. Therefore, x is equal to 14 by 2 means 7. So, one value of x is 7. How to find out the squares? Find two positive numbers whose sum is 14 and the sum of whose squares is minimum. 3 into 100 into 6. So 6 3s are 18 into 100, that is 1800. Hello dear students, welcome to this session of Basic Mathematics Revision class. I am Mr. Niranjan, Faculty Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. In my previous class, we have discussed regarding 2 mark and 3 marks questions. Today in this session, I am going to discuss regarding 3 marks and 4 marks in application of derivatives. So 3 marks and 4 mark questions. One 4 marks question is compulsory from this concept, that is in application of derivatives. So now let us discuss few 3 marker question first, then I'll go to the 4 marker question. Now the volume of a spherical ball is increasing at the rate of 4 pi cc per second. So the volume is increasing at the rate of 4 pi cc per second. Find the rate of increase of the radius of the ball when the volume is 288 pi cc. Now just what is to find the rate of increase in the radius. So dr by dt is to be determined. So the rate of increase in the radius of the ball when the volume, what is the volume? Volume is equal to 288 pi cc. Okay, now very important problem. Now what is given? Just write down, given the volume of a spherical balloon is increasing at the rate, that means dV by dt, the volume of a spherical balloon is increasing at the rate of 4 pi cc per second. Now what is the formula for volume? Volume is equal to 4 by 3 pi r cube. 4 by 3 pi r cube. Okay. Now let us differentiate this with respect to t. Differentiating with respect to t, what we will get? dV by dt is equal to 4 by 3 as it is, pi as it is. Differentiation of r cube is 3r square dr by dt. Okay, now just substitute, find the rate of increase of the radius of the ball when the volume is 288 pi cc. Now substitute the value of dV by dt. What is dV by dt? 4 pi is equal to 4 by 3 pi into 3r square dr by dt. Now cross multiply this. So 4 pi gets cancelled. 3 into 1 is 3 is equal to 3r square dr by dt, or just 3 by 3r square is equal to dr by dt. dr by dt is equal to 1 by r square. Now find out the value of r first. Since volume is given, what is the volume? 288 pi cc. Now substitute here. So 288 pi is equal to, what is the formula? 4 by 3 pi r cube. So that's equal to pi and pi gets cancelled. Cross multiplied. 288 into 3 divided by 4 is equal to r cube. Now what is this equal to? So just divide it. 288 divided by 4, that's equal to 4 7s are, again 4 2s are, 72 into 3. That's equal to 3 2s are 6, again 216. So what is this equal to? This can be written as r cube is equal to 6 cube. What is 6 cube? So just substitute the value of V. What is V? V is given 288 pi cc. Substitute in the formula. V is equal to 4 by 3 pi r cube. V is equal to 4 by 3 pi into r cube. What is to determine? What is to find actually is to find the value of r. That's it. The radius. So cross multiply and divide, you will get 288 into 3 divided by 4 is equal to 72 into 3 is 216. 216 can be written as 6 cube. So therefore the value of r is equal to 6. Now put r is equal to 6 here. That's it. So if you put r is equal to 6, this is 1 over 6 square. That's equal to 1 over 36. So therefore the rate of increase of the radius of the ball is equal to, therefore, the rate of increase of the radius of the ball is equal to 1/36. So what is the unit? Centimeters per second. So therefore, the rate of increase of the radius of the ball is 1/36 centimeters per second. That's it. This is how we are going to solve this problem. Now move on to the next problem. A ladder of this very important problem. A ladder of 15 feet long leans against a smooth vertical ball. If the top slides downwards at the rate of 2 feet per second, find how fast is the lower end is moving when the lower end is 12 feet from the wall. So here what is given? A ladder of 15 feet long. So this is the wall and this is the ground. This is the wall and the ground. This is a ladder. What is the height of the ladder? A ladder of 15 feet. This is 15 feet. Now let us call it as O, A and B. Right. Leans against a smooth vertical wall. If the top slides downwards at the rate of 2 feet per second, find how fast the lower end is moving when the lower end is 12 feet from the wall. Right. So this is X and this is Y. This is given. Find how fast the lower end is moving when the lower end is 12 feet. So this is equal to 12 feet. Lower end is 12 feet. So what is given? Given a ladder 15 feet, that is AB is equal to given. AB is equal to 15 feet. And if the top slide downwards at the rate of 2 feet per second, that is dy by dt is given. Dy by dt is equal to 2 feet per second. Find how fast the lower end is moving, that is to find dx by dt when x is equal to 12 feet. That's it. This is what the given condition. Okay. So from this, if you apply Pythagoras theorem for this, AB square is equal to OA square plus OB square. OA square plus OB square. OA square plus OB square. So what is this? 15 square is equal to OA. OA is x square plus OB square is y square. So therefore this can be written as, therefore x square plus y square is equal to 15 into 15, that is 225, equation number 1. Right. Now differentiate this. Differentiating with respect to t, differentiation of x square is 2x dx by dt plus differentiation of y square is 2y dy by dt is equal to constant. So divide by 2. If you divide by 2, you will get x dx by dt plus y dy by dt is equal to 0. So what is given? What is to find? Just to find dx by dt when x is equal to 12 feet. This is 12 into dx by dt plus what is y? Y is equal to, from this find out the value of y. Y square is equal to 225 minus x square. What is x square? X square is 12 square. 225 minus 144. 225 minus 144 is 81. So therefore y is equal to square root of 81 is 9. 9. The value of y is 9. This is equal to 9. Substitute here. So therefore, so y is 9 into dy by dt. What is dy by dt? 2 feet into 2 is equal to 0. So 12 times dx by dt is equal to minus 9 2s are 18. So dx by dt is equal to minus 18 divided by 12. So if you divide by 6, 6 3s are 6 2s are. So negative sign indicates it is decreasing. Therefore dx by dt is equal to 3 by 2. So 3 by 2 feet per second. That's it. This is how we are going to solve this problem. Now move on to the next problem. Find the maximum and minimum value of the function f of x is equal to 2x cube minus 3x square minus 12x plus 12. This is also an important problem. What is given? F of x is given. So f of x is equal to 2x cube minus 3x square minus 12x plus 12. Differentiate this. Differentiating with respect to x. So f dash of x is equal to, differentiation of x cube is 3x square, 3 2s are 6x square minus 3 2s are 6x minus 12. Because derivative of x cube is 3x square, differentiation of x square is 2x and differentiation of x is 1. Again differentiate this. Then what we will get? F double dash x is equal to 6 2s are 12x minus 6. Now for the function to be maxima or minima, f dash of x is equal to 0. So f dash x is equal to 0 means 6x square minus 6x minus 12 is equal to 0. We can divide by 6. X square minus x minus 2 is equal to 0. Factorize this. 2 ones are, this is x into x, minus and plus, minus into plus minus, the factors are x minus 2 into x plus 1 is equal to 0. Therefore, x is equal to plus 2 and x is equal to minus 1. Right. Now, when x is equal to 2, f dash of x is equal to 0. What is f double dash x? F double dash x is 12 into 2 is 24 minus 6. So, 24 minus 6 is equal to 18. This is positive. Therefore, the function is minimum. The function is minimum at x is equal to 2. Now, therefore, y minimum is equal to, put x is equal to 2 in equation number 1. 2 into 2 cube minus 3 into 2 square minus 12 into 2 plus 12. So 2 2s are 4, 8, 8 2s are 16, minus 2 square is 4, 4 3s are 12, minus 12 into 2 is 24, plus 12. So what happens? Minus 12 plus 12 gets cancelled. 16 minus 24, that's equal to minus 8. So the minimum value is minus 8. Okay. Therefore, y minimum is equal to minus 8 at x is equal to 2. This is one value. Now when x is equal to minus 1, f dash of x is equal to 0. What is f double dash x? F double dash x is equal to, so x is minus 1. 12 into minus 1 is minus 12, minus 6 is minus 18. This is negative. Therefore, the function is maximum. Function is maximum at x is equal to minus 1. So, therefore, y maximum is equal to, put x is equal to minus 1 in equation number 1. 2 into minus 1 whole cube minus 3 into minus 1 whole square minus 12 into minus 1 plus 12. So, minus 1 whole cube is minus 1 into 2 is minus 2. Minus 1 square is plus 1, plus into minus 3 is minus 3. Minus into minus plus 12 plus 12. So, this is 24 minus 5, that's equal to 19. So, therefore, y maximum is equal to 19 at x is equal to minus 1. That's it. So, actually this is a 4-marker question, right? So, the maximum value is 19 at x is equal to minus 1 and the minimum value is minus 8 at x is equal to 2. Now, move on to the next problem. Find two positive numbers whose sum is 14. Sum is 14 and the sum of whose squares is minimum. So, let the two numbers be, let x and y be the two numbers. What is given? So, find the two numbers whose sum is given. X plus y is equal to 14 and the sum of whose squares is minimum. Now, what is y from this? Y is equal to 14 minus x. Now, the sum of whose squares is minimum. Let p is equal to sum of their squares, x square plus y square. Now, just substitute p is equal to x square plus y square is equal to 14 minus x square. Now, let us differentiate this. Differentiating with respect to x. So, dp by dx is equal to, differentiation of x square is 2x and differentiation of 14 minus x whole square is 2 into 14 minus x whole to the power of 2 minus 1 is 1 into differentiation of inside function 14 constant 0, x is minus 1. So, this is nothing but 2x minus 2 into 14 minus x. If you differentiate this, d square p by dx square is equal to 2 into differentiation of x is 1 minus 2 into differentiation of 14 is 0 and x is minus 1. So, 2 minus into minus is plus 2, that's equal to 4. Positive means the function is minimum. So, therefore, the function is minimum. So, that means whose square is minimum. So, how to find out the squares? Find two positive numbers whose sum is 14 and the sum of whose squares is minimum. Now, for the function to be maxima or minima, for maxima or minima, what is the condition? F dash of x is equal to 0. That is dp by dx is equal to 0. In this case, this is equal to 0. That is 2x minus, this is dp by dx. 2x minus 2 into 14 minus x is equal to 0. So 2x is equal to 2 into 14 minus x. So 2 gets cancelled. X is equal to 14 minus x. So just solve for the value of x from this. X is equal to 14 minus x. Transfer minus x becomes plus x is equal to 14. 2x is equal to 14. Therefore, x is equal to 14 by 2 means 7. So one value of x is 7. Now, from equation, y is equal to, what is y? Y is equal to 14 minus x. 14 minus x, put x is equal to 7. Then what you will get? Y is equal to 14 minus 7, that's also equal to 7. So therefore, the two numbers are, x is equal to 7 and y is also equal to 7. Therefore, the two numbers are x is equal to 7 and y is equal to 7. The two numbers are 7 and 7. You can add, what is 7 plus 7? 14. So the sum is 14. Sum of whose squares is minimum, right? So these are the two numbers. Hope you followed. Very important problem. Now move on to the next problem. Show that x to the power of x is minimum at x is equal to 1 by e. This is also very important problem indeed. Now what is given? Y is equal to x to the power of x. Now this can be differentiated by the method of logarithms. So you know what is the derivative of x to the power of x? Differentiation of x raised to x is x power x into 1 plus log x to base e. Right. D by dx of x to the power of x is x power x into 1 plus log x to base e. Right. Show that x to the power of x is minimum at x is equal to 1 by e. So this is nothing but dy by dx is equal to x power x is y into 1 plus log x to base e. Now differentiate this again. Differentiating with respect to x again. Let us represent this as equation number 1. Now differentiating with respect to x, what we will get? D square y by dx square is equal to the product rule, UV method, first function and second function, y into differentiation of 1 is 0, log x is 1 over x, plus second function 1 plus log x into differentiation of y is dy by dx. Now substitute the value of y. What is y? Y is x power x into 1 over x plus this is 1 plus log x into dy by dx from 1 is x to the power of x into x power x into 1 plus log x to base e. Right. Now this can be written as x to the power of, and taken to the numerator it becomes minus 1, x to the power of x minus 1 plus this is 1 plus log x power x into 1 plus log into 1 plus log x is 1 plus log x the whole square. Right. Now what is to prove? Show that x to the power of x is minimum at x is equal to 1 by e. Now put x is equal to 1 by e here. Put x is equal to 1 by e. So that is d square y by dx square at x is equal to 1 by e is. So what is this? X is equal to 1 by e. 1 by e to the power of 1 by e minus 1 plus x is 1 by e to the power of x is again 1 by e into 1 plus log x. X is nothing but 1 by e all the square. So if you observe carefully, this is greater than 0. That means this is positives because e is greater than 0. So positive. Therefore, what do you say? If d square y by dx square, so d square y by dx square is equal to positive means therefore the function is minimum. Therefore the function is minimum at, what is the value of x? That is at x is equal to a. Since d square y by dx square is a positive quantity, therefore the function is minimum at x is equal to 1 by e. That's it. Now move to the next problem. This is a 4-marker question. The edge of a variable cube is increasing at the rate of 6 centimeters per minute How fast is the volume and its surface area increasing when the edge is 10 centimeters long? The edge of a variable cube is increasing at the rate of 6 centimeters per minute. Now let us assume let x is an edge. Let x is the edge of, so the cube of a cube. Let us assume let x is an edge of a cube, right? Given, what is given? Given the edge of a variable cube is increasing at the rate of dx by dt is equal to 6 centimeters per minute. Increasing means it is positive. Now what is to find? How fast is the volume? Volume means dv by dt is to be determined. How fast is the volume and its surface area ds by dt, that is to be determined, is increasing when the edge is equal to, when x is equal to 10 centimeters. So these are the given conditions. So let x be the edge of on each side. Given, what is given? Dx by dt is equal to 6 centimeters. And what is to find? Dv by dt, the rate of change of volume, and ds by dt, the rate of change of surface area when x is equal to 10 centimeters. Okay, so we can call S as the surface area or A as the surface area, or even you use it as R over dA by dt. Now, just write down the volume first. What is the volume? Volume V is equal to, so volume of a cube is x into x into x, x cube. Now differentiate this. dV by dt is equal to 3x square dx by dt. So this is 3 into, what is x? X is equal to 10 square into dx by dt is given, that is 6. So 3 into 100 into 6. So 6 3s are 18 into 100, that is 1800. That's it. Okay. So this is 1000 centimeter dV by dt is equal to 1800 centimeter cube per minute. That's it. So how fast is the volume increases? Means 1800 cm cube per minute. Right. Now surface area. Surface area. S or A is equal to 6 times x square. 6x square. Surface area S or A. Now differentiate this. dA by dt is equal to 6 into 2x dx by dt. 6 into 2 into x is given 10, dx by dt is given, dx by dt is equal to 6. So 6 2s are 12 into 10 into 6 is 60. That is 720. So this is therefore dA by dt. dA by dt means 720. What is dA by dt? Rate of change of surface area is 720 centimeters square per minute. Centimeter square per minute. That's it. Okay. So very simple problem. Given, let us consider x is an edge of each side of a cube. Dx by dt is 6 centimeters. What is to find? dV by dt and dA by dt when x is equal to 10 centimeter. What is the volume? X cube. dV by dt is 3x square into dx by dt, 3 into 10 square into 6, that is 1800 cm cube per minute. And to find the surface area, S or A is equal to 6x square. Differentiated, dA by dt is equal to 6 into 2x dx by dt. Since x is equal to 10 and dx by dt is 6, so 10 into 6, 60 into 12 is 720. So therefore, dA by dt, the rate of change of surface area is 720 centimeters square per minute. That means here the surface area is increasing at 720 centimeters square per minute when x is equal to 10 centimeters. That's it. These are a few problems related to application of derivatives regarding maximum and minimum and rate measure. Right. So hope you followed all these problems. These problems are very important for the point of examination. So that's all regarding today's session. Let us meet with a different concept in the next session. Thank you. Thank you very much.